a whole new area of technology that we're seeing come on stream and be very exciting these days, and that is wearable technology. I'm wearing my Pebble watch today. It's an old first iteration version of it, but I do get my emails buzzed on my wrist here, so I don't have to take out my phone rudely and look at my emails. I can just sort of look like this and see if it's important and carry on. The first of our wearable technology demos today is Chris Gardein. He's Thaumic Labs developer evangelist. What a title that is. And he has a demo of their gesture software called Myo. Through his education in mechatronics engineering and his various technical roles, Chris has developed both hardware and software development skills that allow him to support developers and provide them everything they need to make killer Myo-enabled applications. That's a mouthful. I'm hoping, Chris, that you can make it all clear for us. Chris Goodine.
Thank you, everyone. It's always tough following a keynote, but I will do my best. Today I want to talk about gesture control. Given that we are focused on digital media, I believe gesture control is going to be the future, and everyone here needs to be aware of it. There's no better way to talk about gesture control than with the help of my friend John Anderton, better known as Tom Cruise from Minority Report. So gesture control, this is really the future of human-computer interaction. It allows you to interact with digital content the exact same way you would interact with physical content. And it's no surprise that sci-fi movies indicate that gesture control really is the future. But you have to wonder why. Like, what is it about gesture control that makes it so compelling? Why is it that this is going to be the input of the future? To help understand that question, it might help to kind of go back in time and look at the very first forms of human-computer interaction, namely the computer punch card. So this was the very first way that humans could interact with computers and machines. It was a very difficult process. You need to be trained and skilled, and it was really only accessible to a select few people. It really was the introduction of the keyboard and mouse that made this accessible to a lot more individuals. Now you don't need to be trained or skilled. If you simply know how to read and write, you can interact with a computer. And that opened the door for everyone here to interact with computers. More recently, the introduction of the touchscreen made computing accessible to even more people. You don't need to know how to read and write. You can simply touch and interact with this digital content the way you would the physical world. So this actually opened up the door for even young children. We see kids, they don't know how to read and write. They're 3, 4 years old, but they're still playing games on their iPad. It's very interesting to see. Gesture control is really the next step, and it ultimately will open up computer interaction to infants. As young as 6 months to a year, these individuals will be able to interact with the computers. They don't know how to read and write. They don't know how to touch a screen on an iPad, but they know how to pick up a block and put it on a table. And this is the type of interaction that gesture control enables. Another thing that makes gesture control extremely interesting is the fact that there's a ton of rich content that just isn't captured by the current input devices out there. I'm talking about nonverbal communication. This picture alone, you don't have to look at it too long to know that she's not upset. The truth is there are 55% of communication is nonverbal, and gesture control allows us to take advantage of this rich data. Another thing that's very interesting, and this you kind of see in the sci-fi movies, what I like to say is gesture control allows you to have super productivity powers. You can kind of see this in Iron Man. Tony Stark is a great example of this. He is an intelligent man, but one of the things that makes him so powerful is the fact that he has this technology behind him. He is able to visualize things in his mind and create that content with his own hands using gesture control. And that really is the most important piece. This is really where we're going to go. So at Thaumic Labs, we're based in Waterloo, Ontario. We created a device known as the Myo armband. The Myo armband is a gesture control device in the form of a wearable technology. Actually, if you haven't already noticed already, I'm actually wearing a device right now, and I've been using it to control my presentation. You can see just like that. So what's interesting about this device is that it uses two main sensor groups. The first one is electromyography. A lot of people would recognize this technology in the medical setting. You can imagine those sticky electrodes that you see on a patient's chest monitoring the heart activity. This is electromyographic sensors. Basically what happens is when your brain triggers your muscles to contract, there's a small electrical signal that starts from your brain and it ends up where your muscle is localized. That small electrical signal actually propagates to the surface of your skin and can be detected by a very sensitive electrode. So at Thaumic Labs, we've taken advantage of this sensor technology, and we've actually placed 8 of those EMG sensors across your forearm. We then analyze the activity and start to recognize patterns. For example, if I position my hand like this, I would see high activations in this region of my forearm, and there'd be low activations on the other side. Similarly, if I position my hand this way, I see high activations on this side. So we start to see these patterns across the 8 channels, and now we can start to detect gestures. The next sensor group that we use in the Myo armband is motion sensors. So these are the same sensors. It comprises of an accelerometer, a gyroscope, and a magnetometer. These you would find in your cell phone. It basically allows you to capture the movement and orientation of the device. So you combine an understanding of what you're doing with your hands with an understanding of how you move your arm in space, and you have gesture control. Another thing that makes the Myo armband extremely powerful is the fact that it's a wearable, and more specifically, the fact that it's mobile. So this is incredibly different, and it opens up the door to a ton of possibilities in terms of use cases and applications. Many of you may have recognized the leap motion. This allows you to capture your hand positions and gestures with an infrared-based camera. Similarly, the Microsoft Kinect, it has a little bit more market share. It also uses a camera-based system. The truth is, these are very powerful technologies, and they can capture the fine details of your movements. But unless they have this mobility piece, they're ultimately going to fail as gesture control input devices. To better understand that point, I again want to go back to our history and look at the computers of our past. So we first started off with the mainframe computer, then we moved to the desktop, then the laptop, the smartphone, and we're eventually going into wearable technology. The overarching trend in this evolution is mobility. The truth is, digital content is extremely valuable, and it's come to the point that we want it everywhere. We want it everywhere we go, and we want it in front of us. Now it's getting to the point where we actually want to overlay that content in front of our eyes and see it everywhere we look. In its current state, it's still very young. I bet no one in here is wearing one of these devices, and it probably will be a couple of years before we will get there. But this is where we're going. This is where we're headed. Digital content is going to be everywhere. In its current state, we have, at least with the Google Glass, you have touch and you have voice as your main input devices. But these input devices, they fail. For example, if you're in a noisy environment and you're trying to talk to your glass, the truth is it's not going to work, and it's going to be quite a frustrating experience. And touch, it doesn't always work either. If you're using this in an industrial setting, maybe your hands are dirty or you're wearing gloves. Again, touch will fail. Really, the solution is gesture control. So now that I've sort of given you an idea of what the Myo armband is, a lot of you are probably wondering, what the heck can I do with this thing? How does it apply to digital media? Well, the truth is, we are still a young company. We have only been available on the market and shipping our pre-orders for a few months now. But we're already seeing adoption in the digital media space. Probably the biggest use case in our adoption is DJ Armin van Buuren. He's a world-renowned DJ, and today he uses the device in all of his stage performances. The Myo armband tracks the movements of his arms, and if he raises his arms in the air, the stage effects follow him. He can make a fist and punch his hand in the air, and pyrotechnics will go off. He can point in the crowd and control a spotlight and point someone out. So this is an application that we're seeing already. The next is multimedia. So today, digital content is very static. You just play, pause, and then you go from there. But in the future, digital media is going to be, you're going to be able to play it everywhere you go, while you walk around in your home. And really the fact that you have these input controllers means that the content itself can adapt to this. It doesn't have to be just static content. You can have interaction in the digital content because people will be able to interact with it using these input controllers. And finally, gaming. This is a little bit more obvious, but with gesture control, it really enables you to enter that game and use your gestures and hands to control a character in there. So it's very important for us to realize that this new input form is going to open the door to a ton of different content possibilities. And really, the fact that this device is an open platform means that the possibilities are really endless, and the applications and use cases can really grow from here. Thank you.
Wow. Can you just do that thing with your arm again? Move the sides around? No, it's okay.
Sure, yeah, of course. So what I'm doing here, in case you guys are interested, as I talk, I don't want my gestures to be interacting with the PowerPoint, so I do a simple tap like this, enable control, and now I have control.
Wow.
If it locks up, which it will in a second, now it doesn't.
Chris, can you develop an app, another device, wearable thing that I could put on my teenager and I could control him? That'd be great.
That's version 2.
Thank you, because the gaming one scares me a bit. I've got a gamer in my house and I can just see him doing this at night instead of homework. Thank you, super interesting. Wow, thank you very much.